Okay, before we start going into pandas and starting to work with data frames and do some data analysis, I just want to do a brief detour. And again, this is quite high level, but I think it's important to understand this when you start working with external packages. It's like what does it mean, a Python object and a Python class? And I will give you a very simple example here using a DNA class that we will build together. And this is, you won't build your own classes, but you will deal with a lot of classes and objects in Python. So it's important that you understand the very basics of this. So we have what we've done so far is we've built data flows where we assign variables, then we build functions, and we let the data flow through the functions to give us our results. And that's how you write code in data science mostly, and it's perfectly reasonable. Now, there are other approaches called object-oriented, where you have a second layer of packaging, and you are building these classes, which are which are constructs that hold both data and functions together. And then you can access them very simply by calling that. So you build that using a class initiator, and then you access that the different functions with this dot notation. So you build a variable called DNA, which is constructing this class with this sequence. And then we can just access functions that this class contains and perform coding. And this is how packages are distributed and how functions can be accessed via APIs in the open source world. So I will just show you how the internals of this look like. So you understand a little bit more. This looks very abstract and weird, and you might not understand it right now, but hopefully in the next couple of slides I make this more understandable. So let's build this class DNA sequence. So what classes are their blueprints. They're blueprint for building a particular group of data and functions that are linked together, and that then users can very easily access these and work with these. So here what we do is initially we just build a class DNA sequence, and that is the constructor function here. So it's got this weird double underscore init double underscore keyword. This is just to initiate a function, and then self. So don't worry about that. That just tells it to put things onto itself. And now these are the data that we add to this class. And there's a data type sequence and a data type name. And then we build this. We add this when we are constructing the object using this blueprint. We have to add the sequence and the name as data, and they will be then collected, and we can access this via this dot annotation. So here, for example, we build a gene 1 using this blueprint with this sequence and with this name, and then we can get the name back using saying gene1.name, give me the name of gene1, or gene1.sequence, give me the sequence. So this is just a way of collecting data and packaging them together. And we call this gene1 now an object because it's a larger amount of code that contains different data. So I hope this is clear enough. I have to admit it took me a while, and I'm only when you start writing more complicated, larger code packages, you start using classes yourself. But I think it's quite useful to see how this is constructed. To when you're dealing with pandas, we deal with these dot methods and dot attributes quite a lot. So it's important to get a basic understanding of this. But we will not ask this in exams, and you do not need to build this yourself. I just wanted you to see how this looks like. So uh, at the moment, what we've done is we just collected these two data uh, types within the class DNA sequence, and we can build a gene 1 using this blueprint, or a gene 2, but this is just data at the moment. This data in the terminology of Python are called attributes. So this is an object gene 1 that has got the attribute name and the attribute sequence and has got this particular data assigned to those. But what makes classes powerful is they also have methods mixed in with the data. So that's what we're looking at next. So here we have again our DNA sequence, which is initiated, and now we've defined some methods. So we can have a method length. We can have a method, for example, calculate the GC content. So that will just take the data that are associated with our class and then do a calculation to find out how many G's and C's you got. And a more complicated method, reverse complement. So this is basically putting a lot of functionality on DNA analysis into a single object. So now when we say my gene is equals and then initiate this DNA sequence class with this data. So my gene will have the name my test gene. We'll have the sequence ATCG, 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 and then now we can access these methods of the class. So these functions within a class are called methods. So we can just call mygene.length, and it will use the data that are stored in that class and run these functions, these methods, and give us the output. And the same is we can calculate the DNA content and we can calculate the reverse complement. So within that my gene now, this my gene is not just a variable, it's a powerful object that contains both data and functions, and we can just run my gene length, and to make this more simple, and it will spit out the length, or we can say my gene dot gc content, and sorry, and it will calculate the GC content for this for the sequence that is stored in. So one thing that is important to distinguish is, so there's two things that these objects contain. They contain attributes, which is the data. So for example, name, and you call them. So in our case, it's called test gene. You call them just with the dot and the attribute name. So in our case, the attribute name is name, or we can also say sequence will be the attribute sequence. Okay, and then there's functions or class methods, which are functions packaged into the class, which you have to call with parentheses. So you need this open and close parenthesis, and some methods will take variables as well. So you have to put in the required variable here. And in pandas, we'll use these methods a lot. So now you kind of understand what's going on under the hood here. You have all the code that explains you what my gene actually does. So it collects the data. It has these methods attached. And by calling this method using that dot, we can do quite complicated things. So this is a key concept in coding, where you just package away, you hide away very complicated algorithms behind a hotel reception, and the user can access and asks the receptionist do this really complicated stuff using this annotation, where you say mygene.length. For example, you ask the receptionist, please give me this, and then it goes, executes these functions, and then brings back the data and puts them back. So this is how object-oriented programming works.